Greetings, pre-calculus students, to another day in our unit of sequences and series. In the past couple days, we've looked at this idea of finding the sum of a finite arithmetic series. So arithmetic meaning each term has a common difference, and finding the sum of a certain number of terms within that sequence. Now we're going to look at how do you find the sum of a finite geometric sequence, or in other words, how to find a finite geometric series. So that's what we're going to be looking at today. But before that, as usual, in case the bell ringer was not covered in class, we will go over it right now. So the sum of the first 20 terms of an arithmetic sequence is 100. The first term of the sequence is 2. Find the 20th term of the sequence and the explicit formula for the sequence. Okay, so let's try to highlight the information that's given to us. So first and foremost, we are told the number of terms. We are told 20 terms. So that means n is equal to 20, or the number of terms is equal to 20. We're also told that this sum is 100. Okay, so the sum of the first 20 terms is 100. And then finally, we are told that the first term is 2. So a sub 1 is equal to 2. So once again, recap. Number of terms, 20. Sum of the first 20 terms, 100. First term is equal to 2. So let's set up our formula. So the sum is equal to n, the number of terms, times the first term plus the last term all over 2. Okay, or in other words, this is Gauss's method, right? You line up the sums normally and then backwards, add them up, multiply by the number of terms, divided by 2. So let's see. Once again, we are told that the sum of the first 20 terms is 100, and we're told the number of terms is 20, and that the first term is 2. So that means we don't know what the last term is, which in this case would be the 20th term, right? If you're doing the first 20 terms, the last term would be the 20th term divided by 2. So remember, we can solve this algebraically. So the first thing we're going to do is we're going to multiply both sides by 2. Multiply both sides by 2 to get rid of that division by 2 on the right side. So that gives us 200 is equal to 20 times the quantity 2 plus the 20th term. All right. Now we're going to divide both sides by 20 to get rid of that 20 out in front. So we end up with 10 is equal to 2 plus a sub 20. And then finally, we're going to subtract 2 from both sides, which means that the last term in this sequence is 8. I'm sorry, the 20th term in this sequence is 8. Okay, so the 20th term is 8. All right, well, how does that help us? Well, so we already know the 20th term, excuse me. Okay, so we know the 20th term. All right, so now we have to figure out how do we find the explicit formula for this, because we don't know what the common difference is, and we don't know what the zero term is either. So at this point, you basically have to treat this problem like those problems where we've been given 2 terms, and then we have to determine information about the sequence given those 2 terms. So, once again, we know the first term plus the difference 19 times is going to give us the 20th term, right? Because you would have to add some number 19 times to get to the 20th term. Well, we can fill this out with the information, which is we know 2 is the first term. 2 is the first term, and the 20th term is 8. So let's solve this. So we have 19d is equal to 6. So that means d is equal to 6/19. It's a bit of an ugly number, but that's what it is. All right. First term. Oh, let me make sure I didn't make a mistake here. Find 20th term and the explicit formula. No. So that's our difference, 6/19. Okay. So that means our formula at this point. I'll write it over on this side. Our formula at this point is a sub n is equal to 6/19n plus c. Remember, c is the zero term, or in other words, the first term, if you just went backwards 1 term. So that means c would be equal to the first term 2 minus 6/19, which would be 32/19. So that's our zero term. So that means the explicit formula for this arithmetic sequence would be a sub n is equal to 6/19 n plus 32/19. Let's see, does it work? If I plug in 1, I get 38 over 19, which is 2, so that works. What about if I plug in 20? If I plug in 20, do I get 8? So if I plug in 20 times 6/19 plus 32/19, yep, I get it. So the formula does work. So that's your explicit formula, and that was your 20th term. All right, so let's get to the actual lesson itself. So to do that, we're going to look at an example. Suppose you text a meme to 3 friends on Monday. Each of those friends sends the meme on to 3 of their friends on Tuesday. Each person who receives the meme on Tuesday sends it to 3 more people on Wednesday, and so on. How many people will have received the meme after 8 days? So quickly, just to visualize this, let's just quickly visualize this. So, right, let's say that dot represents you. So on Monday, you send it out to 3 people. Okay, so that's Monday. Okay, now each of those 3 people on Tuesday sends it out to 3 more people. Okay, that's Tuesday. Okay. How many people will have received the meme after 8 days? So in other words, whatchamacallit? How many total people would have seen the meme after 8 days? Well, let's see. Well, we know we start off with 1 person, right? We start off with 1 person, right? 1 person has seen the meme. Then on Monday, it's 3 people. Then on Tuesday, it would be 9 people, right? If you were to just count up each of those points, you would see it's 9 people. So hopefully you can see here that we do have, and the next one would be 27, and so on and so forth. We do have a geometric sequence here, right? Because we do have a common ratio of 3. A common ratio of 3. We're multiplying by 3 to get to the next term. Well, at this point, remember, we're asked, well, how many people will have received the meme after 8 days? Okay, so we're trying to find the sum of a geometric sequence. The sum of a geometric sequence. We know it's geometric. We just have to find the sum. Well, let's see. So after 8 days, so if we assume Monday is the first day, I'm sorry, let me think. Suppose you texted me on Monday. So Monday would be the second day. Yeah, let's assume Monday's the second day, all right? So we start off with 1, so that's the first day, and then the second day is Monday, third day is 9, fourth day is 27. So if we keep going after this, we get 81, 243. Let's see. This time let me make sure I don't make any calculation mistakes. And then 729, and then another one, 2187. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 8 days, right? So on the first day, it's just 1 person. Second day, 3, 9, 27, 81, 243, 729, 2187. So at this point, we just have to find the sum. So the sum, if we add up all of these, let's see what we get. 1 plus 3 plus 9 plus 27 plus 81 plus 243, plus 729 plus 2187. So it looks like 3,280 people would have seen this meme after 8 days. So 3,280 people. So once again, if we consider the first day as just 1 person, and then the second day 3, third day 9, so on and so forth, we end up with 3,280 people as our sum. Okay, and we've known in the past, right? You can calculate a sum by literally just adding up all the numbers. But just as it was the case with arithmetic series, it is the case with geometric series. There is a shortcut. So a finite geometric series. We've looked at a finite arithmetic series. What about a finite geometric series? So the sum of the first n terms of a geometric series is given by this following formula. Okay, so the sum a sub 1, which hopefully at this point you know is just the first term, times the quantity 1 minus r, which recall is the common ratio, to the n power. Okay, so to the n power, which remember that's the number of terms, okay, and then divided by the quantity 1 minus r. Okay, so once again, don't forget, r is just your common ratio. Okay, so as you can see, and then r can't be equal to 1, because then you would end up with a 0 in the denominator. So the common ratio, as you can see, or I'm sorry, this formula ends up looking different than the finite arithmetic series one, right? Because that one was n times a sub 1, or the quantity a sub 1 plus a sub n, all divided by 2. This, on the other hand, is a sub 1 times the quantity 1 minus r to the n power divided by 1 minus r. So this time around, we need to know what the common ratio is. We need to know what that r value is in order to calculate the sum. All right, so let's quickly use this formula in an example. So example 1, find the sum of this sequence. Okay, so I hope this jumps out to you as this is a geometric sequence, because you have a number times another number to an exponent. That's what a geometric sequence looks like, right? I mean, usually our geometric sequences look something like this, times r to the n power, but it's the same thing. Just because the exponent is not n, it's just n minus 1, still the same thing. So now let's use this formula. Well, this formula tells us, all right, so to find the sum of the first n terms, we do a sub 1 times the quantity 1 minus r to the n power all over 1 minus r. Well, let's see. Do we have the number of terms? We do. We start at 1. We end at 6. So that means we have 6 terms. So 6 terms. Do we know the first term? We can calculate it, right? If you always find the first term by just plugging it in. So if I plug in 1, I get 5 times 2, 1 minus 1. So that's 5 times 2 to the 0 power. Well, 2 to the 0 power is just 1. So 5 times 1, which is 5. So a sub 1 is 5. And do I know the r value? Well, the r value is just the common ratio. And remember, that means it's the number with the exponent. So the base number with the exponent is your r value. So the r value is 2. So now I can just plug everything in and solve it. So the sum of the first 6 terms of this series is going to be 5 times the quantity 1 minus 2 to the 6th power all over 1 minus 2. So let's see what we get here. So we get 5, 2 to the 6th. What is that? 2 to the 6th. That's 64. So 1 minus 64 divided by 1 minus 2. So 5 times negative 63 over negative 1. So 5 times negative 63. So what's that? 315? Yeah, 315. So negative 315 divided by negative 1. So positive 315. That is the sum of this series, 315, using the finite geometric series formula. So we got that. Now let's look at another example. Oh, whoops, I forgot that I broke this down. 315. Example 2. Now let's do what we did literally in the bell ringer. If the sum is equal to 13,020 and the common ratio is negative 1 over 5 and there are 5 terms in the sum, what is the first term? Okay? So this time we're working backwards. We're given the sum. So we're given the sum and we're given a common ratio, negative 1/5. So r is equal to negative 1/5. And then we're told that we're doing the 5 terms. So n is equal to 5. What is the first term? Question mark. So let's set up our formula. So s sub 5, because we're doing the sum of the 5 terms, s sub 5 is equal to 13,020, which is equal to a sub 1, which we're trying to solve for, times the quantity 1 minus negative 1/5, which I am going to put inside of parentheses, as you can see. It's a good idea whenever dealing with fractions, use parentheses, to the n power. I'm sorry, we already know what n is, it's 5. All over 1 minus, once again, parentheses, negative 1/5. All right, so let's calculate this. So 13,020 is equal to a sub 1, which we don't know. Let's see, what is negative 1/5 to the 5th power? All right, so let's see. Actually, let me do it this way. There we go. So we end up with 1 minus negative 1 over 3125 all over 1 plus 1/5. All right, let's simplify this further. Let's see, so that would just be... So these two negatives become a positive, so we end up with 1 plus this fraction. So that would just be 3126 over 3125, all over 1 plus 1/5, 6/5. So let's see, I think I'm going to calculate this. I'm going to calculate this side. So I'm going to do 3126 divided by 3125 divided by the fraction 6/5. So let's see, so 13,020 is equal to a sub 1 times, so 3126 divided by 3125 divided by 6 divided by 5. Okay, so I got 0.8336. Divide both sides by 0.8336, and that means divide both sides by 0.8336. So a sub 1 is equal to 13,020 divided by that, 15,619. It's not an exact answer. 0.002 if you round to 3 decimal places. Okay. And there you go. That's your first term. So it's a little bit ugly. It is a little bit ugly, but that is your first term, 15,619.002. That would be the first term of this sum. All right. Now some on your own problems. So for these ones, really quickly, just to clarify something, for these ones you can always assume that you're doing, you can always assume that this is like your last term, in other words. So this is obviously your first term. This would be your last term. So that means you would be doing the first 5 terms, in other words, for this example, just to clarify that when you're using the formula. So n would be 5 for number 1. Number 2, that one actually we're going to quickly, give me a second here. We are going to, quickly, give me a second here. So number 1, definitely do on your own. Yeah, number 1, definitely do on your own. For number 2, let's see. I did want to quickly calculate this one together. Yeah, let's quickly calculate this one because, so for this one, you are not told how many terms you're doing. I mean, you're told that the last term is 46,875, but you don't know how many terms that is. So let's actually quickly calculate that using the information that's given. So you're given it's geometric because I tell you in the instructions that it's geometric. So that means we can set it up as a geometric. So a sub n is equal to a sub 0 times r to the n power. Well, we know the first term is 3, and the common ratio is -5. So that means, if we quickly do this off to the side, that means the 0 term would be 3 divided by -5, right? If you're going backwards, it would be 3 divided by -5. So that's our 0 term at least. So we end up with a sub n is equal to -3/5 times r, which we know, it's -5, to the n power. Okay, so we're going to use this to quickly solve for this. Okay, so we have 46,875 is equal to -3/5 times -5 to the n. So we're trying to figure out what n is. So we're going to divide both sides by -3/5. Okay. So 46,875 divided by -3/5. Okay, so I got, -78,125 is equal to n. Is equal to -5 to the n power. So now you're basically going to be doing some guessing and checking here. What number do I plug in for n so that -5 to that power is -78,000? So let's see. So if I try -5 to the 7th, does that work? Oh, it does, perfectly. That was a complete guess. So it looks like n is equal to 7. Okay, so once again, just guessing and checking. If you plug in 7, -5 to the 7th power is indeed that value on the left side. Okay, so now you know what n is. Now you know what n is when you're using the formula for number 2. Okay, so that was one piece that I did want to show you guys for number 2. All right, so number 1, number 2 on your own, both of them on your own. Number 3 and 4 also on your own. You're basically given all the relevant information, you'll see, once you start using the formula. 5 and 6, same thing. Actually, let me think. The only thing I wanted to show for 5 is one thing. Remember, to find a common ratio, okay, the one little help I will give you for this one. To find a common ratio, remember, all you have to do is take any two terms that are consecutive, so right next to each other, and simply just divide them. So 36 divided by 54, so 36 divided by 54 gives you 2/3. So that means your ratio is going to be 2/3. That is going to be your R value. Okay, so that was just a quick reminder how you find the R value of any given sequence, geometric sequence in this case. So 5 and 6 on your own as well. And then finally, 7 and 8, those are both going to be very similar to that first example that we did. Otherwise, that is the end of the lesson. Hope it went smoothly. As usual, if you have any questions, please let me know. Okay, let me know whether it's during class, whether it's leaving a comment in the Google Classroom, whether it's through email. Let me know if you have any questions. Okay, otherwise, I hope you guys stay safe, and I hope you enjoy the rest